All right, here we're going to take a look at exponential functions, the basic idea behind it. We know that if for this is the definition of an exponential function, a has to be greater than 0 and a cannot be 1. Well, why? We don't want a negative number because think about the value of x. Let's say a is negative 2. Well, negative 2, if x is 1, you get negative 2 to the 1 is negative 2. If x is 2, negative 2 squared, now we got a positive number. If x is 3 for negative 2, negative 2 cubed, we get a negative number. When x is 4, it's a positive. You don't get a nice continuous function. It's all over. We also don't want to consider a equals 1 because 1 to any power is 1, and that's just a horizontal line, y equals 1. So let's consider a is greater than 1. Well, that's exponential growth. When a is a fraction between 0 and 1, it's exponential decay. But I like to show students why, as we all do. So what I do is let's consider the exponential function a half raised to the x. We just show students what happens. What if x is negative 2? Well, we get 1/2 to the negative 2. But in an earlier video with exponents, we know a fraction to a negative exponent is the reciprocal of the fraction raised to the positive exponent. 2 squared is 4. For negative 1, a half to the negative 1, we invert the fraction, make the exponent positive, we get 2. Anything to the 0 power is 1. A half to the 1 is a half. When we take a half and raise a fraction and raise it to a larger and larger power, the overall value gets smaller. So take a fraction, raise it to a larger and larger x value, the overall value gets smaller. But when you take a fraction and raise it to a negative exponent, the larger the negative exponent, larger in the negative sense, the larger it gets, the larger the y value gets, and that's the reason why the shape becomes what it does when a is a fraction.